Okay, we are back again to number 2 questions. If you have missed number 1 question, please you can go to the link and watch the first video. We have solved number 1 question on Futo test questions. Look at the question here. This is Futo test questions, so I'm solving from the questions. Okay. Now this is number 2. Number 2 said evaluate the limits at the given points. So what we have here is this. Solutions. Number 1 is this. We are asked to evaluate the limit as x tends to 2 of x squared minus 4 all over x squared minus 5x plus 6. My students, I believe you all remembered what I told you about limits. That anytime you are given limits at any given point, first of all, obtain your value by direct substitution. That is, first of all, go by direct substitution. It is direct substitution that will give you all the things you need, whether you will solve it by L'Hopital's factorization, personalization, sandwich method. That is, any kind of method you will use will be identified when you apply your direct substitution. So to every limit questions, always apply direct substitution. Now what do I mean by direct substitution? Applying direct substitution, that is 2 directly. 2 is x, so I have 2 square minus 4 all over 2 square, which is this, minus 5 into 2 plus 6. This is already 4 minus 4 all over 4 minus 10 plus 6, which is 0 over 0. So anytime you have 0 over 0, it is called indeterminate form. So it means at this point there is no answer, there is no value, cannot be determined. Okay, so here it now means that there is removable discontinuity here. Okay, there are some functions we can remove for us to solve the limit. Now how do we achieve that? What we have is limit as x goes to 2 of x squared. This is the difference of 2 squares, so we can factorize it to be x plus 2 bracket x minus 2. That is the numerator own. Okay, then all over 2 numbers that can multiply 6 and themselves to give you 6 is 2 and 3. When you add it will give you 5, which is minus 2, so here become x minus 2 bracket x minus 2 minus 3. Okay, if you want to check it back, you multiply. This time this is x squared, this time this is 3x, this time this is 2x, add them will give you minus 5x, so this time this is positive 6. So from here, this can go away with this. So what we have is limit as x goes to 2 of x plus 2 all over x minus 3, which is equals to, let x goes to 2 now, we have 2 plus 2 all over 2 minus 3, which is 4 over minus 1, which is minus 4. So at the end of the day, the answer to that problem is what? Minus 4. Okay? So copy it down. Let us solve the second question. Okay. Now for the second question, remember we are asked to evaluate limits as x goes to infinity, 3x squared, 3x minus this, over 3x minus 3x for x. That is what we have. So anytime you have this kind of function, what you are going to do is to first of all divide by the highest power of x. So we divide by the highest power of x. So from here, what we have is limits as x goes to infinity of 3x divided by 3 square x divided by 3 square x minus 3 square minus x divided by 3 square minus x. I'm done with numerator all over 3 square x divided by 3 square x minus 3 square minus x divided by 3 square x. Okay, so what I'm doing is I'm dividing by the highest power of x, which is 3 square x. So from here, divide numerator and denominator by that. From here, this one will reduce to 1 minus, this one will now be minus x, which is 3 raised to the power minus 2x, all over, this one will be 1 minus 3 raised to the power minus 2x. That is obeying the law of indices. This is minus x, and this one is minus x. So at the end of the day, what we have is what? 1 minus 3 raised to the power minus 2 bracket infinity. In place you see s, you put what? Infinity. All over 1 minus 3 bracket 2 raised to the power minus infinity. Okay? Now, this is equals to 1 minus anything raised to the power infinity, you give us 0, give 1 minus 0, which is equals to 1. 1 over 1 will give us 1. Okay? So that is the end of the